I'm going to substitute for x to find y, and then I'm going to also go back and think about how these transformations are going to change my graph. So for y equals 2 to the x, if x is 0, anything to the 0 power is 1, 2 to the first power is 2, 2 squared is 4, 2 cubed is 8, but then 2 to the negative power is 1/2, 2 to the negative 2 power is 1/4, which means I end up with this horizontal asymptote in this case at y equals 0. And I'm going to try to draw this curve in. Again, it's a little bit easier when you can turn your paper, although they're still probably not going to be beautiful. So my domain in this case is going to go from negative infinity to positive infinity. Again, my variable is x because I'm talking about the values of x. My range is the values of y. It's never going to actually reach 0. Y equals 0 is an asymptote. So 0 is less than y, which is less than or equal to positive infinity. My y-intercept in this case is at the point 0, 1. Now these transformations, I can tell that this is a vertical shrink. I'm going to think of where y equals 2 to the x those points would be, and then I'm going to shrink it vertically. So normally, 2 to the 0 power is 1, but it's only going to be up at 1/2. 2 squared is normally 2, but it's only going to be at 1. 2 to the fourth power, or sorry, 2 to the first power is 2. It's going to be half of that, which is 1. 2 squared is 4. Half of that is 2. 2 cubed is 8. Half of that is 4. 2 to the fourth power is 16. Half of that is 8. And then I'm going to, instead of this being at 1/2, 2 to the negative 1, it'll be at 1/4, but it's really kind of hard to tell any difference on your graph. So try as best you can to draw your curve through those points. I still have this horizontal asymptote, this line that this curve approaches but never actually touches at y equals 0. My domain's going to continue in these cases to be from negative infinity to positive infinity. My range never actually hits 0. So 0 is less than y, which is less than or equal to positive infinity. My y-intercept is only half as much for the y value as it was before. So x is 0, y is 0.5. I notice that this 4 is being subtracted from the x, so it's going to shift this right. This is also called translating it right 4. So normally 2 to the 0 power is 1, but I'm going to take that point and shift it to the right 4. 2 to the first power is 2, but I'm going to shift that right 4. 2 squared is 4, but I'm going to shift that right 4. 2 cubed is 8, but I'm going to shift that right 4, etc. Down here, it's going to be 1/2, 1/4, etc. All I did was just took my curve and translated it right 4. That's not a very good drawing with that asymptote. So my asymptote in this case, and don't forget these arrows at the end because these are infinite curves, is going to still be the horizontal line where y equals 0. My domain is still from negative infinity, less than or equal to x, less than or equal to positive infinity. My range is still 0 is less than y, which is less than or equal to positive infinity. Oops, that looks way too much like an 8. My y-intercept. Well, I could work my way backwards. This was then 1/2, 1/4, an 1/8, so it would be at 1/16. Or I could set up my equation like we did on the logarithmic ones and solve. And we'll actually set up those equations on the next one. So I'm noticing this is going to go left 2 because of the x plus 2 and down 5. So again, normally 2 to the 0 power is 1, but I'm going to go left 2 and down 5. 2 to the first power is 2, but go left 2 and down 5. 2 squared is 4, but go left 2 and down 5. 2 cubed is 8, but go left 2 and down 5. 2 to the fourth power is 16, which would be off the graph, but, well, actually in this case it is still off the graph. So, not off the graph by much though. 16 minus 5 is 11, so this would actually cross here at 11. And I notice that if this should be at 1/2, this should be at 1/4, going down to the next thing. So, fourth away from that, I should say. It's actually, in this case, if it's a half, it's -4 1/2, and a fourth would actually be -4 3/4, etc. So my asymptote has shifted down 5. So it's at y equals -5 now. My domain is still from negative infinity, less than or equal to x, less than or equal to positive infinity. My range, it never actually reaches a y of -5. So -5 is less than y, which is less than or equal to positive infinity. Y-intercept, I can tell, is at the point 0, -1. X-intercept, yeah, I can't tell where that is. So I have to solve for my x-intercept. My x-intercept is when y is 0. So 0 equals 2 to the x plus 2 power minus 5. I would add 5 to both sides to say 2 to the x plus 2 power equals 5. I can't go any further in exponential form, so when I'm stuck, I switch to the other form, which means the log base 2 of 5 equals x plus 2. Now I'm going to use my change of base here to be able to evaluate this logarithm. So the base 10 log of 5 divided by the base 10 log of 2 would equal x plus 2, but if I want to solve for x, I'm going to subtract 2 from both sides. When I plug this in my calculator to 2 decimal places, I get x equals 0.32. So my x-intercept is where x is 0.32 and y is 0. Now, a quick heads up. They could do some really sneaky, tricky stuff. Let me erase this. You need to go back and pause it so you can finish copying at any point you can. They could do some weird things like, actually, let me go into one of these. Well, either way, they could do y equals the opposite of the log base 5 of 2x. Remember, this means that it's reflected across because the change is on the y, the change of sign is on the y. If I change the sign on the y, I reflect across the x-axis. If instead, let me do this. They did this and changed the sign on the x. Oh, the x has a change of sign. So when I change the sign on x, I reflect it across the y-axis. I'll give some of those problems to you in a little while to practice those as well.